Welcome to Cadence Design Systems Fidelity Tutorial Tuesday, where we show you how to use our fully integrated environment, Fidelity, in short videos of a few minutes. In this video, I'll cover the main features linked to creating bodies from comma-separated data files. Fidelity allows importing 3D curves in the geometry context through comma-separated data files. Here's an example of a CSV file describing the NACA 2412 airfoil, which follows the format requirements of Fidelity. The first line contains the header with the definition of the coordinates x, y, and z. The second line contains the 3D coordinates of the first data point. The next line contains the 3D coordinates of the second data point, and so on. One CSV file can also contain multiple curves. In this case, each curve is separated by a line containing only the separator. The file of this example contains two airfoil profiles representing the root and tip section of a wing. The import mode import curves from CSV files can be used to control the imported 3D curves. There are also additional parameters under options. The imported curves can be defined as polyline, B-spline, C-spline, or Bezier curves. By default, the curve type polyline is used and the control points are connected by consecutive straight segments. The C-spline option can be selected to obtain a smoother curve in case of small datasets. The closed curve option automatically adds segments to each imported curve in order to obtain a closed loop. Here, for example, checking this box will guarantee that the profiles are closed at the trailing edge. Lastly, planar surfaces can be automatically created by checking the Create a Surface from a Planar Closed Curve option. The result is an assembly containing two boundaries, the profile of the wing root and the profile of the wing tip. Further geometry transformations can be applied to the tip profile if its boundary is converted to an assembly. Let's twist the tip section by 3 degrees in order to ensure that the effective angle of attack of our wing is always lower at the wing tip. Finally, the wing pressure and suction sides can be created using the Create Lofted Surface tool. For that, select the root and tip profiles and click Apply. From here, the next step would be to create the domain for an external aerodynamic analysis. This is the subject of another video. Thank you for watching. If you like this video, be sure to click the thumbs up button to subscribe to our channel for more upcoming content like this. If you have any questions or suggestions for future videos, please drop us a line down below or connect with us on LinkedIn, which is linked in the description. Thank you all and have a great Tuesday.